Every time you flip a switch to turn on a light, plug in your smartphone to charge, or activate your fan for a cool breeze, electricity is actively moving and working behind the scenes. It's a fundamental force that powers our modern world, making countless daily tasks possible and convenient. But have you ever paused to consider the intricate process of how this invisible energy travels so seamlessly and efficiently through the complex network of wires that connect our devices and homes? It's a question that delves into the very heart of electrical engineering and material science. The remarkable secret behind this smooth and continuous flow of electricity lies within a special category of materials known as conductors. These materials are essentially the true highways of electricity, providing an unobstructed path for electric current to travel, much like a well-maintained road system for vehicles. On-screen text: conductors equals easy path for electricity. At its core, a conductor is defined as any material that readily permits electric current to pass through it with minimal resistance. This unique property is what makes our electrical systems function, allowing power to be delivered where and when it's needed, from the smallest microchip to the largest power grid. The fundamental reason for a conductor's ability to facilitate electrical flow lies in its atomic structure. Conductors possess what are called free electrons, tiny, negatively charged particles that are not tightly bound to individual atoms. Instead, these electrons are free to move throughout the material structure, creating a mobile charge carrier system. When an external electrical force, known as voltage, is applied across a conductor, these free electrons are compelled to move in a directed manner. This organized, collective movement of electrons constitutes an electric current. The greater the number of free electrons and the easier they can move, the better the material conducts electricity. To put it in a more relatable context, you can think of conductors as being analogous to smooth, multi-lane highways specifically designed for electric charges. These roads are wide open, free of obstacles, and allow the traffic of electrons to flow quickly and efficiently from one point to another, ensuring a steady supply of power. Conversely, materials known as insulators act in direct opposition to conductors. Insulators effectively block the flow of electric current by tightly holding onto their electrons, preventing them from moving freely. They are like roads with impenetrable barriers, trapping electrons and preventing any significant current from forming, thus serving as protective shields. When we look at common materials, most metals stand out as excellent conductors of electricity. This includes familiar elements such as copper, which is a staple in wiring, aluminum, often used in power transmission, and even more precious metals like silver and gold, known for their superior conductivity, though less common in everyday applications due to cost. Copper, in particular, holds a prominent position in the electrical industry. It is extensively utilized in the manufacturing of almost all electric wires, from the thin strands in your headphones to the robust cables in your home's electrical system. Its widespread use is attributed to its exceptional efficiency in conducting electricity, coupled with its relatively affordable cost and ductility, making it easy to draw into wires. While silver boasts the highest electrical conductivity among all metals, making it the best conductor known, its prohibitive cost makes it impractical for most general-purpose electrical applications. It is typically reserved for specialized components where superior performance is critical, such as in high-end electronics or sensitive scientific instruments, where even a slight loss of efficiency cannot be tolerated. Aluminum cables are another common sight, especially in large-scale electrical infrastructure. They are frequently employed in overhead power transmission lines, where their lighter weight compared to copper is a significant advantage for long spans between towers. Aluminum offers a good balance of conductivity, strength, and cost-effectiveness for these demanding applications. It's also crucial to understand that even seemingly harmless substances can become conductors under certain conditions. For instance, pure water is a poor conductor, but water with dissolved salts or impurities can conduct electricity quite effectively. However, this can be extremely dangerous, as contact with electrified water can lead to severe electric shock. Always exercise extreme caution around electricity and water. The presence and function of conductors are ubiquitous in our daily lives, often going unnoticed despite their critical role. From the moment you wake up until you go to sleep, You are constantly interacting with devices and systems that rely on these essential materials to operate. They are the hidden pathways within the walls of your home, forming the intricate wiring that powers your lights and appliances. Conductors are also miniaturized into the complex circuits found in your smartphones, laptops, and other electronic gadgets, enabling them to process information. Furthermore, they are etched into the microscopic pathways inside the sophisticated computer chips that drive modern technology, facilitating rapid data transfer. On a larger scale, high-voltage power lines, which crisscross our landscapes, predominantly utilize robust aluminum conductors. These powerful lines are engineered to efficiently carry massive amounts of electricity over vast distances, from power generation plants to substations, and ultimately to our communities, minimizing energy loss along the way. Within the heart of many machines, copper coils play an indispensable role. They are essential components inside electric motors, where the interaction between magnetic fields and electric current flowing through these coils generates the mechanical motion that drives everything from electric vehicles to industrial machinery. These coils are meticulously wound to maximize efficiency and power output. Imagine a world without conductors. Electricity, a vital force, would be effectively trapped at its source, unable to traverse distances or power our devices. It would be like having a powerful engine with no roads to drive on, rendering its potential useless and leaving our modern world in the dark. Conductors are the unsung heroes that bridge this gap, making it possible for us to transmit electrical power safely, reliably, and efficiently across entire cities, vast rural areas, and directly into our homes and workplaces. They are the backbone of our electrical infrastructure, ensuring that energy reaches every corner of our interconnected society. So, now you possess a deeper understanding of these remarkable materials. Conductors are not just simple wires. They are the indispensable highways that keep electricity moving, enabling the technological advancements and conveniences we often take for granted in our daily lives. They are fundamental to how our world operates. In our upcoming video, we will shift our focus to explore their equally important counterparts, insulators. These materials serve as the protectors of electricity, preventing unwanted current flow and ensuring safety. Stay tuned to learn how they safeguard our electrical systems and prevent hazards. On-screen text. Next, insulators, the protectors of electricity. If you found this explanation enlightening and want to continue exploring the fascinating world of science and technology, please don't forget to like this video, share it with your friends and family, and subscribe to our channel for more powerful and insightful science videos from K2 Creative Hub. Your support helps us create more educational content.